already we have covered up to data independence in three schema architecture. That is the advantage of three schema architecture. That is data independence. So the last topic of the first chapter, that is advantage of DBMS. So now while discussing about the advantages, all the advantages you cannot understand at this moment now. Okay, because all the chapters have not covered till now. So just uh, now just see this and follow the headings. Later you can understand it better. So advantages of DBMS is controlling redundancy and inconsistency. Controlling redundancy and inconsistency. Then one is that is redundancy means actually repetition. So using DBMS, we can control redundancy and inconsistency. If redundancy means repetition, so if there are redundancy of data, that means same data is repeated a number of times. So that is leading to wastage of time and wastage of space, obviously, because the repetition needs a space. So that leads to wastage of space and searching time also. And if the data is inconsistent, that is also not desirable. So DBMS is controlling and reducing the redundancy or repetition as well as the inconsistency of data. Uh, um, Let me give you one example. For example, a number of persons are booking ticket from the website. Now there are 200 tickets are available. Now, when at a moment when a person can get the ticket, then at that moment the number will be reduced to 199. It is not that the a person has got the ticket, but the number is still 200, so that the other users can be get confused, so that there are 200 tickets are available. This type of inconsistency will not occur in case of DBMS. Okay, so that is one very much simple example. Uh, and next one is restricting unauthorized access, thus ensuring security. That is, already we know that in case of DBMS, all users cannot access all the parts of the database. He or she needs the access grant, and the access grant is given by the database administrator. So if database administrator is authorizing the access to a particular user to particular part of the database, then he or she can uh, access that part of data. So uh, so in this way, in case of DBMS, the security is ensured. Now, easy access or efficient access, obviously, when we can see in our lab that using a single command we can easily access the table of the database. Then multiple users. Obviously, multiple users are there. For example, when we are booking ticket, multiple users are booking ticket, and all of them are accessing the same database. All of them accessing the same database. So here, multiple users are there who are concurrently accessing the database. Okay. And also, due to concurrent access, the consistency will not be lost. Will not be lost. Okay, the database will be consistent. And data independence, that already you have gone through that. What is data independence? Already I've told that data independence is the advantage, a most important advantage of DBMS, so that we can change any level without disturbing the its upper level, without without making changes to the upper levels, and provide backup and recovery, that we will see. um, in case of a transaction, we will see that the database administrator should take the backup and also take the recovery in case of system failures. So these are the advantages that are not the cases with the file system. So that's why we uh, motivate ourselves to use the DBMS to store and access a database rather than a file system. So here, that is the definition of a query. Now, what is a query? Now, query is a statement requesting the retrieval of information. Okay, that means a query is the statement when only we asking or requesting for a retrieval of some data. But informally, all the types of request, that is updation or here it is that creating tables, updating tables, inserting data, all the type of commands are called queries informally. Okay. Now already uh, uh, all of you have already done the lab part. So there you know the language that is used, that is called SQL, structured query language. So in the structured query language, it is divided into three categories, that is DDL, DML and DCL. Okay. Now already I have told the full form of a structured query language, that is SQL, that is structured query language. Uh, because this is a very important question in case of DBMS Viva, both in lab and theory. But at the end of the semester, I cannot find a good answer or correct answer from all of you. So that's why I'm writing it, structured query language. Okay. Now three categories are there. One is DDL, that is data definition language. Data definition language, that is, DDL. Then data, I'm writing it for your understanding so that you can remember it properly. Data manipulation and note it down because these are the important questions. Data manipulation language or DML, and data control language or DCL. Okay, so these are the three full forms of DDL, DML, and DCL. So now, uh, so DDL works on the schema of the table. DDL or data definition language is working on the schema of the database or structure of the database. So already you have done the create table. So using create table command, you can create the structure of the database. You are just making the structure. So create is an example of DDL. Okay, carefully remember the examples. Now already you have done um, insertion. Now DML is to uh, data manipulation language. Um, and DML means data manipulation language. So DML is working on uh, instance of the database. Okay, so obviously when you are inserting a data, the instance of the table will be changed. When we deleting a data, the instance of the table will be changed. So uh, so already you have done the insert into table. So insert into table command is of example of DML. And also later we will see that delete, update, that are also belong to DML. And DCL example we will not cover till now, that is mm, commit, revoke, grant, that also we will uh, 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 see in the next examples. Okay, so these are the three categories of languages, and must remember the examples of this. So in the next so up to this all of you have understood the DCL, DML, all of you have understood properly?
Yes, ma'am.
Okay,
Yes, ma'am.
so then I will start. Okay, okay. All of you have understood. So, I will start now a new chapter, that is entity relationship model. Okay. The first chapter we have covered. So, um, entity relationship model. First, already we have um got an overview of the entity relationship model. That is, here the main things are entity. So, what is an entity? Entity is a thing in real world with an independent existence. So entity is a real world object with an independent existence. It may be an object with a physical existence or with conceptual existence. Now, the person and house this are of physical existence. Obviously they are physically existing, but the thing objects that is like a company or a project or course that are not physically exist, so but they are also considered as object or entity. Okay, so two types of entities we found, that is one is with physical existence, that is person, student, teacher, house. They are of um, physical existence, and some objects are there or entities are there that is that are with no physical existence of those projects, code, marks, subject, company. These have no physical existence. Now the attributes. Now next term is attribute. Now particular properties that describe entity is represented by its attributes. So particular properties that describe the entity, and an entity is described by its attributes. So that is the definition of attribute, that particular properties that describe the entity. So an entity is represented by its attributes. So a particular entity has a value for each of its attributes, obviously. Um, so collection or set of entities with the same attributes uh, are called entity type. Um, so that is, for example, entity type means what is the difference between entity and entity type means that is, for example, I am a teacher, so myself an individual entity, but mm, the uh, set of all teachers. Okay, that means that is the teachers who are teaching you. The set of all teachers are making the entity type. So that is the teacher entity type consists of all the teachers who are teaching you having the same attributes. Teacher ID, teacher name, then for example address, then degree, then subject taken. These are the common attributes of all the teachers. And myself, Mandira Bonik, is a single teacher. So I am a single teacher entity, and all the teachers are making the teacher entity type. Okay. So all of you individual. Okay, if there are 60 students are there, so 60 different entities of student are there. But when we are talking about the student entity type, then we are taking the whole set of the students. Okay, so that is the difference between entity type and a single entity. Uh, So each simple attribute of an entity type is associated with a value or a set of values, values that can be assigned to that attribute for each individual entity. So the set of values that can be assigned to the attribute for individual entity, those value sets are specified by data types. So we will later see that already we have seen your lab session that data types are there. Mm, so data types means the type of the data or set of the allowed data that can the particular attribute uh, have for the particular entity. Okay, so a particular attribute can have a set of values. So those set of values are specified by data type. Okay, and there is another term that is domain. So domain and data type means, domain means the range of values that are allowed. For example, the pin code, uh, or for example the marks. The marks will be type of integers or number. The data type of the marks will be number, but the domain of the marks is of that is from 1 to 100. So that is the domain of the marks. Okay, so that is the difference between domain and data type. So up to this, any problem?
No, ma'am. Okay.
Okay, up to this it is okay. Okay. Um, so let us see the different types or categories of attributes. That is, um, first of all, that is simple attribute and composite attribute. So So composite attributes are that can be divided into smaller subparts, which represent more basic attributes in with independent meanings. So composite attributes are that can be divided into smaller subparts, and subparts represent more basic attributes with independent meanings. For example, address. So address can be broken into parts, that is I can address can be broken into parts, that is street address, city, state, and pin. Now street address can be again broken into house number, then street number, then mm, then street and apartment number. So you can see that the address is broken into a number of parts, because address actually consisting of street address, city, state, pin. So street address again divided into street address, then street name, then apartment number. Okay. Similarly, name of a person may be subdivided into parts: first name, then middle name, then last name. Okay, so that is the composite attribute. So name is a composite attribute, address is a composite attribute that can be broken into a number of subparts. The subparts are also are the basic attributes with independent meanings. And simple attributes are those that cannot be divisible. So these are the two categories, simple and composite. Next one is single valued versus multi-valued. Rohan, any
Ma'am,
problem?
yes, ma'am. Ma'am, name itself is a simple attribute or composite attribute? Name itself.
Name, how can you represent it? It depends on that. If you represent name in terms of first name, second, middle name, and last name, then it's a composite attribute. Or
Okay,
if
okay.
you just represent it as a simple attribute, just um, uh, only name, then it may be considered as a simple attribute. Okay, most of the cases it's considered as a simple attribute, but address is obviously a composite attribute. Okay.
Yes, yes, yes. Okay, ma'am. Fine. Thank you.
Mhm. So next one is single valued multi-valued attributes. Okay, so attributes that are having a single value for a particular entity, uh, that is called single valued. Attribute having a single value for a particular entity, that is called single valued. And attribute having a set of values for some entities, those are called attributes. For example, phone number. So phone, for a particular entity, the phone number attribute are having multiple values, because a person may have a number of phone numbers. So phone number is a multi-valued attribute. And but the name of the person, that cannot be multi-valued. Obviously, a person should have only a single name. So name of the name attribute is a single valued attribute, but phone number attribute is multi-valued attribute that can hold a number of values against a particular entity. Okay, so that is the single valued and multi-valued. An entity type that describes, so that is the thing. And it is just written that an entity type describes schema for a set of entities that share same structure. That I have told. Entity type is represented by ER diagram. ER diagram we will see later. So diagrammatic representation of ER model is known as ER diagram or ERD. So okay, and the next category of attributes are stored and versus derived attribute. For example, you are storing the DOB persons in a database. So DOB is a stored attribute. Now from the DOB attribute, you can easily calculate the age of that person. So, uh, so that is The age is the derived attribute, and DOB is the stored attribute. Okay, so that is the thing. Now null value. Now wait, it is the class. Now one thing. So up to this, any problem about the types of attributes, different categories of attributes? Any confusion is there or any problem? Okay. Okay. Now let me show one thing. Um, um, all of you can see it properly, or should I make the slideshow? All of you can see it properly. Is it clear to you? Is it
Yes, ma'am.
properly visible? Okay.
Yes, ma'am.
Okay, okay. As it is properly visible, then it's okay. Um, so this is the ER model. Now, entity relationship model is proposed by Peter Chen in 1976. So, it is an important question for your MCQ. The ER data model was developed to facilitate database design by allowing specification of an enterprise schema that represents the overall logical structure of a database. The ER model is very useful in mapping the meanings and interactions of real-world enterprises onto a conceptual schema. Because of this usefulness, many database design tools draw on concepts from the ER model. So the ER data model employs two basic concepts. One is entity sets, one is relationship sets, and another one is attribute. So entity sets and entity type are similar, and relationship sets is that I'm a teacher, so uh, the relationship between a teacher and a student is the teachers. So when if I am considering individual student, so I have a relationship with the individual student, that is I teach individual students. So that is the 1:1 relationship. But when I say that I'm a teacher, I teach the students, a set of students, then it is a relationship type. So a single relationship between single entities are called a relationship, one a single relationship, and the set of relationships like this are called the relationship type or relationship sets. So teacher teaches student. This teaches is a set of relationships between multiple teachers and multiple students. Okay, because you are also taught by a number of teachers. So as a individual student, you have all of you individual of you have a relationship with each of the teachers. That is, you are taught by the individual teachers. So that one is to one relationship is a single relationship. And when we are considering the total set of the relationships, then we are saying it at relationship type. And next one is attributes. So ER model has an associated diagrammatic representation that express the overall logical structure of a database graphically. So that is already I have told this. Just I'm revising it from the PPT, that an entity is an object that exists and is distinguishable from other objects. Entity set is a set of entities of the same type that share the same properties. Okay, that is written here. Set of all persons, companies, trees, holidays. Those are entity set or entity type. Now, entity is represented by a set of attributes, descriptive properties possessed by all the members of an entity set. Now, uh, look at this here. We are writing that instructor or teacher is basically consisting of these attributes. So you may say that it is the schema of an instructor that is consisting of these attributes, and in our later chapters we also represent entities in this way, that it is because the data always doesn't matter. The main thing is that the schema of the table. So schema is consisting of these attributes. Now course is consisting of course ID, title and credits. So in this way we are giving examples of entities. So a subset of attributes. Okay, this primary key I leave it now. Later I will discuss about it. So go to the next slide. So see here, two different entities, and already we know that in entity relationship model, the data are represented using table format. So here we can see two tables. One is customer table representing the data for customer entity, and another one is loan table representing the data for loan entity. Um, so these two entities are represented in this way, and we can say that the customer entity, that is Hayes, is a customer entity. Account, a particular account is the account entity, and the relationship between these two entities are the depositor. So depositor is making the relationship between a customer and account. That customer is depositing money in account. So depositor is the relationship. Uh, and this mathematical notation you may leave it now, because now it will be difficult for you to understand this mathematical representation. uh, Later we will focus on it. So you can say that the Hayes and A102, these two are belonging to the depositor table. So when we are making the table for depositor, obviously we have to keep there the name of Hayes or the name of the customer who is holding the account A102. Okay, so that is the depositor relationship, that is consisting of the customer name and account number. So we can see that the between the customer and loan, the relationship is borrower, because between customer and account, the relationship is depositor. Between customer and the loan, the relationship is borrower. Okay, because all the customers are not taking the loans, so that is a different set of entities. That customer, that is the same, and the another entity is loan. So you can see that here single relationships are shown between Jones and this loan account. Okay, so Jones is associated with this loan account. Then Smith is associated with two loan accounts. Okay, you can see it. Smith is associated with two loan accounts. Okay, then the particular loan account L17 is maybe a joint account of this Jones and Williams. Okay, so, and similarly Curry is associated with the loan account L19. So these are the single relationships, and the set of all relationships are consisting the relationship type. uh, so next one is the attributes that already we have gone through. And domain, already I have told you the set of permitted values for each attribute. Attribute types are simple and composite, already you know. Two are given two simple attributes are role, marks, salary, uh, that consist of single atomic values, and composite attributes that can be decomposed further, that is a name and address. And single valued, multi-valued are also phone number, email ID, these are the multi-valued, and single valued are the employee ID or roll number that cannot be duplicated. Okay, so now in the next slide you can see that is the derived attribute, already we have discussed. Now going into the details of null attribute and key attribute, I will show you first that, see how the composite attributes are represented. See, in this way the composite, so name is the composite attribute, address is the composite attribute, and this first name, middle name, last name, or street number, street name, apartment number, these are the component attributes. Okay, so these component attributes are the simple ones, so they cannot be divided into more parts. Okay, see here we have broken the address in two stages. Okay, again the street is also decomposed. Uh, so next we will go back to the term that is a null attribute or null value. So null value means an attribute whose value is missing for a record. Okay. Um, for example, in a table you have added two columns, that is for example, okay, you have added two columns, that is phone number 1 and phone number 2. Now all the person may not have the two phone numbers, so So all the phone numbers. So phone number one and phone number two. So all the persons have not uh, two phone numbers. So for all records, you cannot get the value of phone number two. Some persons you can get the value for phone number two, but for all the persons you cannot get the value for phone number two. So that's why. So for the phone number two column, we can say that we get empty or missing values for some of the records. The record for which the persons who has not a second phone number. So that value is called null value. Or the phone number two, you may say it that. It is a null attribute. Sometimes its value may not be found, may be missing. Now there is a difference between null and zero. For example, there is options for students that you can give exams for subject 1 or subject 2 or both. So some students have given the exams for both subjects, and some students will give exam have given exam for only one subject. So then uh, so for example, the subject giving exam for subject 1 is mandatory and subject 2 is optional. So for subject 2 we will get that um, for all students we will not get marks because all the students have not appeared for the subject 2. So for some records, some rows, we will get empty values. So those values are called null values. And the students who have given exam for the both subjects, some of them may get 0 in the subject number 2. So for subject number 2, in the marks column, we will get that some records are not having any value for marks for subject number 2, and some records having a marks 0. So that is different. 0 and null values are totally two different things. Okay. So up to this, any confusion? What is the difference between null and zero, and or all the things till now I have discussed? Any problem, or it is okay? Okay, okay. Um, then the next term is next topic is key attribute. So key attribute is that an attribute of an entity type for which each entity must have a unique value that is called a key attribute. That means the attribute that is unique for each entity, that is called a key attribute. So for example, through the key attributes we can identify the each entities individually or uniquely. For example, the roll numbers of the students, that cannot be that are the unique things. Okay, so uniquely we can identify the students using the roll number. But because the names, even the surnames of the students may be same, in that case the only identifying attribute is the roll number. So roll number is the value whose value is unique for each of the student. So that is called key attribute. For employees or for faculties, faculty ID or employee ID is the key attribute. So then we will go for the thing that is this one. ER diagrams. So in the ER diagram, you can see that it is the diagrammatic representation of ER model. Here the rectangles are called the represents the entity sets, not single entities, entity sets. Okay. And diamonds represent the relationship sets, because in this customer entity all the customers are represented by this customer entity. Okay. So it is entity type or entity set. So rectangles represent the entity types, diamonds or rhombus represent the relationship type, and lines link the attributes to entity sets and also link the entity sets to relationship sets. So and the ellipses that represent the attributes. The ellipses are or ovals are representing the attributes. You can see it. So the ellipses are representing the attributes. Now double ellipses represent multi-valued attributes, and dashed ellipses represent derived attributes. That we will see in the next slide. See here, double ellipses represent multi-valued attributes, and dashed ellipse is representing the um, derived attribute. So this is the. So also here we are showing the composite address is divided into a number of parts. So the customer entity, it has a number of attributes, and all the uh, composite attributes, simple attributes, multi-valued attributes, derived attributes, all are shown. And see here, one underline is given. So the key attributes are denoted in the ER diagram by giving an underline with it. Okay. So that is the notation for the entities and attributes. Now, here you can also see that the customer ID, the loan number, these are underlined because these are the primary keys or key attributes. They are called primary keys or key attributes. Um, Now, relationship of a attribute. Uh, sorry, attribute of relationships. Till now, we have seen the attributes of entities. Okay. So till now, we have seen the attributes of entities. Now we will see the attribute of relationship. For example, if you see this one, um, Here it is a customer. It is actually the content of depositor table, where the customer names are given. Not the all details of customer table is given here. Customer details are given in the customer table. Account details are given in the account table. That what is the account number, what is the IFSC code, what is the branch number, what is the balance. All the details of accounts are stored in the account table. Here, only in the depositor table, only two columns are there. One is customer name and the another one is the associated account name. The customer is associated with which account. Now in that table also, if you add another column, that is access date. That means on which date the particular customer is accessed the particular account. Okay, so because here you can see that Johnson, he is accessing uh, the account A101 on 24th May, and he is also accessing the account A201 on 17th June. So one customer may access the different accounts on different dates, and also account, for example, A201, that is accessed by Johnson on 17th June, and that is accessed by Smith on 21st June. So you cannot specify the access date as the property of customer, because a customer is the access date is cannot be only property of the customer, because the access date is not fixed with the particular customer, because a customer is accessing a different account on different date, or it is not a property of account, because account can be accessed on different dates. So if it is a property of account, then it should be associated with account. Then beside a particular account, which access date you can write, because for an account it can be accessed by different persons on different dates. So access date is not a property of the account. Also, it is not the property of the customer, because beside a against a customer you cannot write a single access date. You have to write a multiple customer access date, because a person access different accounts on different dates. So that's why we can say that the access date is actually the property of the relationship depositor. So here, if a depositor is a table, then we are keeping there the columns, that is customer name, account number, and access date. That means the particular customer accessing the particular account on particular date. That means Johnson 8101 24th May. Johnson A201 June. Okay, so that's why we can say that the access date is the property of the deposited relationship. So mainly attributes are the properties of entities, but sometimes we can see that the relationship sets also are having the attributes. Okay, so up to this, all of you understood this attribute of relationship set. uh, okay, because it is not a attribute of customer as well as account, it is attribute of the depositor relationship. Okay, Um, so next topic is degree of a relationship. Okay. Uh, okay. I think today already we have covered enough. So I will continue on the next class, because on a single day, if I give so much resources, you may not take into in your brain. Um, so I think I now should I continue or should I stop? What is your suggestion? I have no problem. That means, are you ready to take more resources or should I stop? Okay. Mm, actually, tomorrow you have the class from 4 p.m. But I'm not sure that whether I can take the class tomorrow. Mm, in that scenario, I can take the class on Friday, because tomorrow I may have a meeting from 4 p.m. So if I cannot take the class, then I will take it on Friday, because already I have taken the lab for the second group also. I already told it on the Monday that on the Monday I have taken the labs for two groups, and I'm taking it on each Monday. I'm taking the joint lab. So today I will not continue. I stop here, and maybe tomorrow or day after tomorrow we will have the class. Okay, so I will let you know. So I'm ending my session. Thank you.